Welcome back to my YouTube channel. In today's video, I'm going to be doing a tutorial on an aspect in differentiation, which is titled chain rule. Okay, so in today's video, I'm going to be doing an introduction to this aspect, and I'm also going to be solving an example or some examples if the time permits. Okay, because I have a time bound for every of my videos. Okay, so let's look at some of the examples or some of the questions that you can use chain rule to solve. Example, y is equals to u raised power 2x. In this case, you can't just differentiate this directly because there's no if you look at the normal differentiation, you will notice that there's nothing like a raised power 2x. Instead, it is what a raised power x that you can differentiate normally. Okay, and something like y is equals to what cos square x, something like y is equals to what cos open bracket 3x minus 1, and something like y is equals to what 3x minus 2 into brackets is power 9. Okay, so basically I can say that chain rule is used to simplify a differential expression. This is from my own definition. This is my own definition of what of chain rule, since it involve you introducing an alphabet into question, then I can say that what is used to simplify. Okay, so without wasting much time, let's commence the main topic for today or the main discussion. But before then, please do well to click that subscribe button and also do well to click that like button. And please, this one I'm begging you for it. Please do wish to share this video. There are a lot of people that need this video, but they can't get it without you sharing it. Please do well to share the video. Thank you. Okay, so let's start. So let's assume we have to differentiate an expression titled an expression y is equals to what f of x. Okay, so you know that this also represents like an expression of function of x, right? And let's assume is this function of x or this expression, permit me to use the word expression for this video, is not something like x squared or we're asked to differentiate x or this thing. It's something like all those questions that I displayed earlier on or that was written on the screen earlier on. Okay, so now you can't just differentiate those questions directly. Okay, so in this case I'm going to introduce an alphabet to simplify my expression. That means I'm going to make an assumption that what u is equal to what x. Okay, so this x in this case can mean anything. It's just like you. Okay, don't let me rush. Okay, it can mean anything. Okay, so now what this u is equal to x means is that wherever I see x in y is equal to what f of x, I'm going to replace it with what with u. Okay, so now imagine the question is now something like y is equal to what e raised power what 2x, and you assume that what your x in that case, your u in that case is what is 2x. Then you notice that your y change to what y is equal to what e raised power u. That means it means that wherever I see 2x and y is equal to what e raised power 2x, you replace it with what with u. So in that y is equal to what e raised power u, you can differentiate it directly. But if you differentiate it directly and you assume that you have arrived at your final answer, then you're wrong, because you were being asked to differentiate with respect to x, but now you're differentiating with respect to your value. Okay, I'm sorry for skipping, or I'm sorry for being in a rush. So let's continue slow, one after the other. Okay, so now if I want to differentiate my y, that means after my y I've done to what y is equal to f of u. I can't differentiate my y with respect to the initial differentiation, that means the y over dx. I'll have to differentiate it with respect to what to u, because if I differentiate it with respect to my initial dy over dx, my f of x will turn to 0. That is one thing I needed to note. Okay, so I have to differentiate it with respect to u. Okay, so that will give me what dy over du is equal to whatever you differentiate from your expression. Okay, so now I also have to differentiate my u with respect to what x. So that will give me du over dx. The next thing is to look for an expression or a formula that will join both of them together without changing the initial assumption of the question. So that was how chain rule basically come about, or that was how it came about in my own expression, please note. So now the formula for showing you for this question, it is what the y over the x is equals to what the y over the u times the u over the x. Okay, so now after this basic explanation of chain rule, let's apply this concept to a question, or let's use this concept to solve a question. Okay, so now the question I'm going to be solving in this case is y is equals to what? A raised by what? 2x. And please note, the e I'm referring to in this question is exponential, not alphabet e. Okay, there are two different statements. Okay, so now I'm going to make an assumption that my u is equals to what? 2x. Okay, so if I make an assumption that u is equals to 2x, it means that wherever I see 2x in y is equals to e raised by 2x, I'll replace it with what? With u. So that will give us what? Y is equals to what? E raised by u. Then if you look at, like, if you go through the basic table for differentiation, you will notice that what you can differentiate e raised by x directly, but in this case it's not e raised by x, it's e raised by u. That means you are differentiating with respect to what? With respect to what? U in this question. According to the formula, I need to find the y over the u and the u over the x. Okay, and okay. So now the next thing is to what? Differentiate u with respect to what? X. So if I differentiate u is equals to 2x with respect to x, I'm going to have what? The u over the x is equals to 2. How? Using the normal differentiation. That means if you differentiate a x raised power n, to give what? A times n x raised power what? N minus 1. Okay, so if I use that scenario to give me what? 2 times 1 x raised power what? 1 minus 1, because 2x is also written as what? 2x raised power 1. Okay, so now let's differentiate y, my new y, which is y is equals to t raised by u, with respect to u, not x. Because if we differentiate it, let's differentiate it with respect to u. Okay, so I'm going to have what? The y over the u is equals to what? Is c equals to what? E raised by u. Okay, if I differentiate e raised by x, it's going to give me e raised by x. If I differentiate e raised by u, it's still going to give me what? E raised by u. Okay, so now let's apply the formula to this question. That's what the y over the x is equals to what? The y over the u times the u over the x. Then insert your values. Okay, so if I insert the values into this expression, I'm going to have what? E raised by u times 2. Okay, so that can be written as what? 2 e raised by u. Don't forget that your u is what? U is equals to what? 2x. So you insert the values. The value of u, I'm going to have what? The y over the x is equals to 2 e raised by 2x. So this is the final answer for this question, and thank you for sticking along with me. Okay, if you want me to solve the remaining question, or to create a tutorial video for the remaining question, please comment it below. Okay, so I'm going, if the number of comments meets the number I like, the meet a convincing number, okay, let me put it that way, I'm going to then create a video. If not, I will leave it to you. And please, if you are able to solve those questions that I displayed at the beginning of this tutorial, please do well to comment it below, and don't also forget to share this video. Please, it's very important. Share, subscribe, and like. And again, if you too say you should rate the video, please rate my video very well. Thank you.